Alright, in the last video we set up our two constraints that we're going to have, making sure that each city is only serviced by one factory and making sure that each factory is only putting out upwards of 2,500 pounds of fertilizer. So now that we have those constraints in, it's time to calculate out what the revenue matrix is going to be. So this is going to be our our revenue minus the cost of production minus the shipping charge for each one. So let's start out with Boston, and we're going to write an equation, and we are going to start with, let's roll it up here a little bit, we're going to start out with our price. That's how much money that Boston is going to be sending us. And then we're going to have to subtract some stuff from that. So we do have a production cost and we do have a shipping cost. So that production cost, what is that going to be? That's going to be the quantity of fertilizer that we have, and then we're going to multiply that by our production cost per pound. And now the next thing that we have to do is we have to subtract our shipping costs. So our shipping costs are going to be based on, because this is shipping cost per pound per mile, so we will go right with, there's once again how many pounds of fertilizer I have, and then it is 2 cents per mile, and then I have to multiply it by how far we're going to ship it, and so that's where the distance matrix comes into play. So in this case this would be Boston to Boston, so that would be our shipping charge. And so if I execute that there, that means that if I make the fertilizer in Boston and ship it to Boston, I'm going to end up making $61,000 before I worry about fixed costs. So that's my revenue, which started at $75,000. So we're losing about $14,000 to the shipping charges and to the production charges. Now, I only want this to pop up if I'm actually shipping from Boston to Boston. So what I'm going to do is I'm going to take this entire equation and then I'm going to multiply it by my binary variable in the Boston to Boston shipping. Because if we're not making it, we want it to be 0, and if we are making it, we want it to be that number. So if we decide not to ship to Boston and put in a 0, that ends up becoming 0. But if we are going to ship to Boston, we end up getting that 60,000. Now, I do want to replicate this over the entire matrix. So, I definitely want that B26 to freely index across. That's not a problem. Our production cost and our shipping per pound, we want that to freely move left and right. Or, sorry, those are locked in. They can't freely move left or right. So we have M11. M11, what was that? That is our price. Now, we don't want the column to index, because we want it to stay in that price column. But as I pull it down, if I go from Boston to Chicago, I want it to slide from Boston to Chicago. So what I'm going to do is I'm going to put a $sign in front of the M. So that means that the column will never change, but the rows will. And then what we have is we have our L. So the L's in this equation are all dealing with our quantity. And so we do want the quantities to change, but once again, we don't want the column to change. We always want it to stay L, but we want the rows to be able to change. So what I'm going to do is I'm going to come and put a $sign in front of the L, and then in front of the L. So we've controlled how the M and the L columns are going to change. B11, that's our distance matrix. We want that to go completely around, and that is our customer matrix. We want that to go completely around. So if I hit enter, so I have my thing set up the way that I want it, and now we just need to replicate that everywhere. We can click and drag over, we can click and drag down, or we can Control C and then just highlight this entire thing and say paste the equation. And so there we go. Let's go and just click on one of these randomly to kind of check. And this is Miami to Denver. So Miami to Denver, Miami to Denver. Sorry, LA to Denver, not Miami. I was wondering why that didn't work. So LA to Denver, LA to Denver, and LA. So everything seems to have come together nicely just the way that we want it. So I'm going to just come here. I want to change this because when you do the copy and paste, you can see it kind of messes up the border a little bit. Just going to get rid of the border and then put the border back in. And so depending on if I hit that, it'll calculate out what the cost is going to be. Obviously, if we send stuff from Miami to Boston, that doesn't seem like a good idea because we're going to lose money, but that's fine. Okay, so the next thing is that we have to do is we have to take care of these fixed costs. Well, these fixed costs are going to be pretty simple. So we're just going to sum up the number of factories that we have open, and then we'll multiply that by the monthly plant fixed cost. So right now we've got 2 plants open. It's going to be $120,000. Last thing we do is profit. Profit's going to be the sum of all of this stuff here. So these are all of our monetary inputs minus our fixed costs. So we can just sit there and just simply go sum and highlight this entire thing, and it will just sum up everything in that matrix from B41 to I48, and then we subtract our fixed cost. And at this point, the spreadsheet is set up. We have our objective to maximize profit. It's ready to go. We have our decision variables, a pair of binary variables. So this binary variable up here is whether or not the plant's open. This binary variable down here is what cities each plant is servicing. We have our capacity coefficient here, our capacity constraint here, and then we have our servicing constraint here. So now let's go and put that right into Solver. So data, Solver, go to our objective, which is our profit, which right now is at negative 22,000. Not so good. We want to maximize that. We want to do that by changing the open plant cell, comma, and then all of these servicing ones. Now I could have put a range name in here just to have it show up on our little, show up as words here on our little solver, but I didn't do that. If we wanted to make it really pretty, we can go back and do that. So I want to add some constraints. The first one is the pounds shipped out has to be less than or equal to the capacity. I forgot to switch boxes there. Go over here. That has to be less than our capacity. And our capacity is controlled by whether or not the plant is open. Say OK. And actually, let's add our number of plants that can service has to be less than or equal to the number allowed. And so we have less than or equal to in there because that allows this number here to be 0. If I made this equals to, that would force us to fill all the orders, and we'll take a look at what happens if we do that later. And then I'm going to add, because I want to add 2 more, I want this to be a binary constraint, so we'll take it down to binary, force it to be 1s and 0s, and then I'll take this and force that to be a binary constraint. Say OK. Alright, so we do have some that aren't named here, so if I wanted to do that, I'd come back and I thought I'd put a range name in here. Apparently I did not, so we'll come here, we'll just give this a range name so our solver looks a little bit better. So formulas, create from selection, left column. And then over here, we'll highlight this and I'll just give it a name. We'll call it plant service. Did I spell that? Service. And so that's just another way to name it. So now this matrix has a name. This matrix has a name. And we'll come over here and we'll just update our range names. So unfortunately, the only way to really do it is delete it, using formula, paste names, paste list. Okay, so let's go back to our solver now, and all that will be updated. And there we go. So now everything's got words associated with it. And so let's hit solve and see what happens. You can see this one's taking just a little bit longer because there's a lot of stuff going on. It's going through things. So it found a solution. All constraints are optimally satisfied. That's the happy box there. And we'll come over here and we'll see that we can make $110,464. Now, as we go and look at things here, so what are we going to do? We've got the Boston plant, the Denver plant, the New York plant, and the Phoenix plant open. The Boston plant is just servicing Boston. The Denver plant is going to get Dallas and Denver. The New York plant's taking care of Chicago and New York. And the Phoenix plant is fulfilling Phoenix. Also notice that Miami, it wasn't worth it for only 830 pounds of fertilizer at $21,000. They decide there's no optimal solution that includes that. And so if I go and look here, we can see there's all of our revenues minus our production costs that we have for each of those. $240,000 in fixed cost and totally monthly profit. Okay, so they'd left one out. So what would happen to this if we said that we had to fill all the orders? Because obviously it's like, oh, well, we fill all the orders, we'll make more money. And Solver told us, well, we won't. But let's see what would happen if we have to fill all the orders. So number serviced by, we are going to change that. We're going to take that to an equals to. And say, okay. And so that's the only change we make. We'll solve. And we'll let it run and see what happens. So it found a solution. So by fulfilling all of them, you can see, so the change, Boston now fills Boston and Chicago. Denver still fills Dallas and Denver. New York now fulfills Miami and New York. And Phoenix picks up LA and Phoenix. So we still have 4 plants open, but because of the extra shipping charge, you can see that we're only making $99,000. So we're going down about $10,000. And as you can see right here, we are losing money shipping to Miami. So it's definitely, at this case, it's better to not pick up that extra business because that's not really helping us all that much. And we're also losing money because before New York to Chicago was $20,800, but now we're only making $18,000 off the Chicago run because we have to ship it out of Boston instead. And so that combined with the money that we're losing there, that's why we're going down by $10,000. Okay, so this is a little more complex one because we've got a lot of things going on, but hopefully that showed you the power of being able to use binary variables as decision variables to turn on and off different parts of our solutions. With that, that's the end of this problem. I hope everybody understands what's going on. If you do have any questions, please let me know. Otherwise, I will see you in the next video.